Let's take this problem of the chapter of the uh, first problem says two spherical bodies, each of mass 50 kg, are placed at a separation of 20 centimeters. The placed at a separation of 20 centimeters. This separation is 20 centimeters. Center to center distance is 20 centimeters. Then each of has a mass of 50 kg. Each has a mass of 50. Next it says that equal charges are placed on the bodies. Let us say two equal charges Q and Q are given to these bodies. And it is found that the force of the Coulomb repulsion equals the gravitational attraction in magnitude. That means we know that the force of Coulomb attraction is given by F. Let us say Coulomb attraction force is equal to 1 upon 4 pi epsilon 0 into Q1, Q2, Q1, Q2 by R square, where R is the distance between them. And also we know the force of gravitational attraction, let us call it Fg. Force of gravitational attraction is given by capital G, which is a universal gravitational constant, M1. R is the same distance between them. Gravitational constant is G, M1 multiplied by M. Here, what is given? It is given M1 is equal to M2. 50 kg it is given. Also, we know that 1 upon 4 pi epsilon 0, this value the students need to remember that is, it is 9 into 10 to the power 9 Newton meter square by Coulomb square. Also, the value of capital G, that is the universal gravitational constant, this value also students need to remember. It is 6.67 multiplied by 10 to the power minus 11 Newton by kg cent. So what do you find? What do you find? The Coulomb force. What do you find? The Coulomb force. That means the Coulomb force is 1 upon 4 Q1 and Q2. Let us consider both Q1 is equal to Q2 equal to Qc. So it is Q square divided by R square. This is equal to G into M1, M2, both M1, M2 are 50 into 50 divided by R square. Now, this R square and this R square gets cancelled. So what we are left with is square is equal to G. G is 6.67. 6.67 into 10 to the power minus 11 multiplied by 50 square, that multiplied by 4 pi epsilon 0. And 4 pi epsilon 0 is given here. So this is 1 upon 9 into 10 to the power 1 upon 9 into 10 to the power 9. All this. If you calculate this, you will find Q is, you'll find this is equal to 1 852 minus 20. From there, we find Q is equal to divided by 2 to the power minus answer. Let's go to the next question. The next question from the same chapter of this. The next question says, a satellite is projected vertically upwards from an Earth station. Right? Let us consider this is the Earth. This is the Earth station. Let's consider this is the Earth station. And it is projected, satellite is projected vertically upward. Right? Question is, at what height above the Earth's surface will the force on the satellite due to the Earth to be reduced to half its value at the Earth station? Now, there is a force on it when the satellite is at the Earth station. And it is given, the radius of the Earth is given. So let us say the Earth is given 6,400. When the body is here, there is a certain force applied by the Earth. The force applied by the Earth at this point is equal to, let's say the force here is F1, then F1 is equal to G multiplied by M, that is mass of the Earth, multiplied by small m, the mass of the satellite, divided by R square is 600 whole square. And let us say this is a certain height h where the force is F2 and F2 is half of F1. F2 half of F1. And when that is when the satellite is at the height h. So F2 is equal to, from here we find F2 is equal to, again applying by the same formula, G, capital M, small m. Now the distance from the center of the Earth to the satellite, this distance is R plus H whole square, R plus H and its whole square. Then by the equation, F2 is equal to F1 by the given problem. So we find G capital M small m divided by R plus H whole square is equal to M small m divided by R. Obviously, here this G, M, M and G, M, M gets cancelled. So what we are left with is R plus H whole square is equal to, oh, sorry, there is a multiplication of halves. So R plus H whole square is equal to, from here we find by taking under root on both sides, R plus H is equal to root 2. Therefore, from here we find that H is equal to root 2R minus R is equal to minus 1 into R, where R is given as 6,400 minus 1 multiplied by 6,400. If you calculate this with your calculator, you will find this is 650 kilometer. The answer That is, when the satellite is at a height of 2650 kilometer from the Earth, then attraction on it will be reduced to half. Then there was the attraction when it was on the surface of the Earth, that is at the Earth station. Let's go to the next problem. The next problem says the geostationary orbit of the Earth is at a distance of about 3600 kilometers. Let us consider this is the Earth. Let's consider this is the Earth. And it says its geostationary orbit is at a distance of 3600 kilometers from the Earth's surface. That is, from the Earth's surface to the orbit is 3600 kilometers. And question asks, find the weight of a 120 kg equipment. Now, this 120 kg is when the body was here, its weight is 120 kg. Question is, find the weight of this 120 kg equipment placed at the geosphere when it is here. Then what is its weight? That means what is the force on it downward by the Earth? By the way, I think many of you know what is geostationary orbit. If you do not know, geostationary orbit is such an orbit that when a satellite is placed here and the satellite keeps on moving, at the same time, Earth also revolves, then the velocity of this satellite and the revolving velocity of the Earth is such that the satellite always keeps on looking at a certain point of the Earth. That means Earth also revolves, the satellite also revolves. So Earth is always above a certain, so satellite is always above a particular point on the Earth. Anyway, radius of the Earth is given as 6400 kilometers. This radius of the Earth, R is 6400 kilometers given. Also given, mass is, this is not kilometer, it should be kg. And mass of the Earth is 6 into 10 to the power 4 kg. The question is, find the weight of the body when it is at the geostationary orbit. That means what is the force F1? Equation by the gravitation we know. Force F is given by G into product of the two masses divided by R square, where R is the distance from center to center. And this R, when it is at the geostationary orbit, R is equal to 6400 kilometer, plus 36,000 kilometer, 36,000 kilometer, which is equal to 4 to 400 kilometer, which is equal to 4 to 4 to the power 5 meter. So this is the distance. Now just use this equation. You don't have to do anything more. If you use this equation, F is equal to G is, we have to always remember, 6.67 into 10 to the power minus 11. Mass of the Earth is 6 into 10 to the power 24 kg. Mass of the Earth is 6 into 10 to the power 24 kg. 6 into kg. Mass of the body is 120 kg. R is this much, 424 pi, that has to be squared. If you calculate this, you will find the equation. The answer is 27. Answer is 27. Now, by the way, though you don't have this in this problem, let us find out what 27 Newton means on the surface of the Earth. If a body of mass m is on the surface of the Earth, then mg is equal to 27 Newton, where g equal to 9.8. Therefore, m equal to 27 by 9.8 is equal to 2.75 kg. This shows that the body, which is actually 120 kg on the surface of the Earth, appears to be 2.75 kg when it is in the geostationary orbit. So these are the three questions. And next day we shall see the next chapter, the chapter of Newton's laws of motion, right?